Okay, so welcome back. Now, it's fairly likely if you've been using computers for any amount of time, you've probably come to the realization at some point that some of your storage media, your SSD, your M.2, your hard drive, is getting full and you need to figure out what you're going to do. You need to either delete files or you need to move them somewhere else. And especially nowadays when we're talking about gigabyte and terabyte storage, it's fairly likely when you start to get those storage media full, it means you've got many, many thousands of files and folders that are taking up the storage space. And to find the large files and large folders that will help to be deleted or moved, it becomes a bit of a chore. So for example, I've got here on my D file, which is a 500 gigabyte SSD, I go to my Documents folder and I can right click, go to Properties, and you can see it's giving me some data about that folder and all of the subfolders and sub-subfolders and all of the files in that main folder. And you can see there's about 145 gigabytes of storage being used on that 500 gigabyte SSD. And down here it tells you there are 73,000 files and 18,000, almost 19,000 folders. So you get to the point where you say, wait a minute, I've got to search through 19,000 folders to find the files that are taking up a lot of space, because deleting 2 kilobyte files isn't going to help me. I need to find where the really big files and folders are so I can start working on those. So what we're going to do is we're going to help you build this application, C# Visual Studio Windows Forms application, that will help you with that task. So let's go and show you what this does. So I click Get Folder, and I go down to my D drive, and I select my Documents, hit OK, and now it will go through and get folder sizes. And it's telling us we're going D Documents. It's got 71 direct subfolders. We said it's got thousands and thousands of folders, but directly under this D Documents, there are 71 subfolders. And it's calculating for all those subfolders and sub-subfolders the size of each of those 71 subfolders. And here is the list that it's giving us. It's starting out with some that are 0 megabytes, and we can consider whether we want to delete those because they don't have any data. And it goes up to the two highest users are this folder with 78,000 megabytes and this other one with 26,000 megabytes. So it's gone through 71 folders and all of the sub-sub-sub-folders under each of these folders and given us a total storage requirement. And it says the total main directory size is 149,000 megabytes, which is about what we saw right here, 145 gigabytes. So now we can sort through these and say, these are the guys that are causing the trouble, and we can figure out what to do. And then what we can do is we can go into these large capacity folders and then do this again to get the subfolders that are using the most amount of space and so on. So really great way to sort through and find what are the folders and subfolders that are taking most of the storage. So now the first thing we're going to do, unlike what hobbyists and newbies do, we're going to actually design this rather than jump in and start writing code and getting lost and going down a rabbit hole and wasting time. Especially with this project, because it turns out this can be kind of complicated, this project. And in fact, there are going to be some issues that we're going to realize that you probably never ever would have thought of. And you're not going to notice those issues until you've actually finished this and tried it out and said, oh shoot, I forgot to consider that. So it's really important that we understand exactly what we're doing. So the first thing is we're going to have our main directory that we tell the application, here's the directory we want to look under. And we are going to have some subdirectories under that main directory. And the goal is for each subdirectory, figure out all of the files and the sizes and add them all together for each subdirectory. You see here we've got subdirectory 1 is 12 megabytes, 2 is 0.046 megabytes, and 3 is 18 megabytes. And what we're going to do, once we've got that, we want to have it sorted like we showed in the application with the lowest value storage first and sort it up to the highest value storage. So we're going to also need to not only associate the storage with the directory, the main subdirectory, but also figure a way to sort those. Now, in the real world, we're going to have something that might look like this, where we've got the main directory, we've got 1, 2, 3 subdirectories. And in those subdirectories, you might have files alone. We're going to have to add up those storage values for the files. But also, you might have one or more or hundreds of subdirectories. So since we want to know a total for each subdirectory, we're going to have to allow for the fact there might be 10 subdirectories under each main subdirectory. So we're going to have to do some recursion to make sure we've captured all of the files in all of those subdirectories. So that's where this is going to get kind of challenging. So we're going to have subdirectory 1 with some files. We're going to have subdirectory 2 with multiple subdirectories, and then subdirectory 3 with some files. Now, with that said, the task that we're going to have to do, if we write out kind of the pseudocode for our main directory that we specify, first we're going to have to get a list of all of the subfolders under that main directory. We're going to have to get a list of subdirectory 1, 2, and 3. Then for each of those subfolders, we're going to have to get a list of files and file sizes if they exist. So for subdirectory 1, we've got 2 files, and we'll have to get the sizes of those. Subdirectory 2 has no files, but it does have a subdirectory with files. So for each subfolder, we're going to have to get a list of files and file sizes, and then add them up. So we're going to have to add 10 plus 2 for this subdirectory 1. But then we're going to have to repeat the first step. So for example, subdirectory 2, we already know it's a subdirectory, but we have to repeat for each subdirectory. We're going to have to go through the same process. So there's going to be a lot of recursion going on to make sure we've got all of the subdirectories. So this is the basic task list. Now we got to figure out what we hope to find in .NET or .NET Framework that will help us with that. Well, to get the list of subfolders, we're hoping there's going to be something .get directories. So it'll give us some sort of array or list of subfolders. And then for each subfolder, we have to have something .get files, which is going to give us an array or a list of files. And then we're going to have to, for each of those files, get a file size so that we can add them all together. So we're going to be looking for something like this get directories, get files, and get file size. And then we're going to have to figure out how we can do recursion through all of those. So in system.io, there are some classes that we can look into. One is the directory class, one is the directory info class, and one is the file info class. And I encourage you to look in the Microsoft, learn.microsoft.com, in the .NET API browser. There's the system.io namespace. And over here on the left, you might see a lot of things that look familiar. For example, Stream Reader, Stream Writer, you've probably worked with when you're reading and writing from files. And what we've got here is things like directory, we've got directory info, we've got file info, and those are the ones we can look at to see if they can help us with these tasks. So if you look at the directory IO class and look at the explanation, it says it exposes static methods for creating, moving, and enumerating through directories and subdirectories. Aha, that might help us. Directory info exposes instance methods for creating, moving, and enumerating through directories and subdirectories. So they sound very similar, but one is static methods and one is instance methods. And then file info provides properties and instance methods for the creation, copying, deletion, moving, and opening of files, and aids in the creation of file stream objects. So these are the three things we can look at. Maybe we can benefit from those classes to be able to get lists of folders and to get file sizes and that kind of thing. Well, if you dig into this a little bit more, the directory class has a get directories method. However, what it does is it just returns an array of string names of all of the directories. And it also has an enumerate directories, which returns an IEnumerable string, but again, it's just the names of the directories. And then it's also got in the directory get files, again, it's arrays of string names and an IEnumerable of string names. Down here, we've got directory info. As we said, it looks very similar. However, it returns directory info arrays, arrays of directory info. So instead of just names, it's going to give us some information. So it sounds like this directory info might be of more use. So get directories is an array of directory info. Enumerate directories is an IEnumerable of these directory info objects. And then directory info files is get files, which returns an array of file info objects. And then enumerate files is an IEnumerable of file info objects. So it turns out we're going to focus mostly on this directory info because, again, we need not just names, we need like sizes or lengths of the files, and we need a little bit more information. So we're going to try to focus on this directory info class and some of the methods. Now there's also, when we get these returned for a directory, we get an array of file info objects or an IEnumerable of file info objects. Those file info objects allow you to get the files in that list or that array, and from that we can grab, as you can see down here, directory info has the name, the extension, the parent. The file info has name, length, which we can use, that is, how many bytes of storage, directory name, and so on. So we're going to focus on these directory info and file info classes to get the data that we need. So now let's take a look at our C# Visual Studio Windows Forms application and see how we get this thing working. First of all, we've got our design, basically just a text box, multi-line text box. You drag and drop. I've got the scroll bar enabled, vertical scroll bar. And then we've got 3 buttons. One is the user clicks to open a file dialog to get the folder name to start with. And then once we got that, we're going to go through and iterate through all of the subfolders to get all the subfolder sizes and then exit. Now in the form 1, the using statements, using system, system.collections, system drawing, system.io. We talked about this, is going to be very important. And then system.windows.forms. We've got, as we usually do, docs to do. And then we've got some properties. When we said we're going to sort the folders, the subfolders, based on how many megabytes of storage is inside each folder, we're going to use what's called a sorted list, and I'm going to call it dir list. A sorted list that we're going to put the folder name and the total size of all the files in that folder into a list. It's kind of like a dictionary. We're going to use directory info and we're going to call it folder, and we'll use that later. And then directory total size, we're going to initialize this as a double, where we're going to continue to add up all of the size of all the files in that directory. And this one is a 0, we're not going to use yet, we'll use it later on. So basically we started up, initialize component, and I've just enabled and disabled the buttons when we don't need them. But the first thing we're going to do is we're going to do the event handlers. And the methods, there's only one method we're going to use. The second one we're not going to use yet. But this is called folder size. You basically feed it a directory info object. We're going to call it folder. And it will calculate the size of all the files. But the main thing is the event handler. The first one is the get folder, where the user tells us where to start, what's the main folder. And we're going to use what's like an open file dialog, but this is a folder browser dialog. We're going to call it FBD, is new folder browser dialog. And the same as we do with an open file dialog, show dialog, if that equals dialog result OK, then all we're going to do is we're going to grab the directory info, and we're going to call it folder, that describes that main folder. And we're going to use FBD, whatever the user selects, we're going to create a new directory info. So now we can operate on that main folder and check all the subfolders. And then here we're just enabling and disabling and changing the color of the buttons. So now we go to calculate the sizes of all the subfolders. So I'm just changing the back color. And here we are printing out for the user, okay, here's the folder that you selected. And this returns a string for the folder name. Now what we can do is for that directory info folder object, we can use the get directories we talked about before. And that will give us an array of directory info objects, and we're going to call it subfolders. And then we can iterate through each of those. And now we're going to feedback in the text box, num folders, and we can use the subfolders.length, the directory info.length of that array to show us how many subfolders. And then we're going to say we're calculating all of the sizes. Now we're going to loop through every subdirectory and get the size of each. So we're going to use a for each. For each directory info, we're going to call it dir in subfolders. We're going to say the total size of the directory is that folder size for that directory info directory divided by 1024 by 1024, which is going to give us megabytes, because we're getting it in bytes and we're going to convert to megabytes of storage. And then directory total size, we're going to increment every time we get this folder size. We're going to increment to get a final folder size for that folder. Since we're using a sorted list, and that has key value pairs just like a dictionary, comprised of directory megabytes and directory name, those are going to be the key and value pairs. Make sure the key is unique in case there are directories with 0 size. And if there are 2 directory sizes that are identical, we'll get an error about non-unique keys. So we need to implement a try-catch to merely ignore those cases. Not the best solution, but anyway. And this is one of the issues I said you're not going to think about until you actually do it. And we'll probably talk about this in the next video, how to clean this up. But we're saying if the total size of the directory is greater than 0, then try to add the total size of the directory and the directory name as keys and values to this sorted list. And if not, it's an exception. So we're going to loop through each subfolder, and then for each dictionary item in this directory list, we're going to send to the user string.format, the item value and the item key. Now this sorted list automatically sorts the values in an increasing fashion. So it will automatically do the sorting, which is one of the nice things about this sorted list. So we're going to print out for each folder, it's going to give us the value, and then we're going to print out the total of the directory total size, and this other one, inaccessible, we're going to talk about later, and then finished. And that's about it. So we can run this. We specify D, documents, OK, and now get folder sizes, and it will tell us we're in D documents, 71 subfolders, and here is the results. So now previously I mentioned there are some problems that you probably never thought of, but you'll probably encounter when you run this. After a bunch of trial and error, it may suddenly pop up. One of those is you will likely at some point get an unauthorized access exception. If you do this code on files or folders that don't have the right access, you could get this error. And one of the problems is in our directory info and our file info, and they will try and get all of, for example, all of the directories of the folders. And if they encounter one that has this error, it might crash your program. So you got to do some thinking about how can I make this work so that if it gets this exception with one file in this long list, how can I gracefully either ignore that or do something else to make sure that the application doesn't crash. So turns out this can be a difficult issue that you never expected, and we'll talk about this in the next video. Also, we mentioned using the file size in this sorted list as the key, where we've got the file size and then the associated name of the folder or the directory. If we get files that are of the same size, it might crash because you won't have unique key values. So we also need to think about, is there a better way to implement, instead of this sorted list, maybe there's another way to do this. There's also some other issues that you can encounter on this. We'll talk about in the next video. But that's it for this one. If you're liking these videos, I encourage you, hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.